Hey Math 33, today I'm going to be solving number 3, I believe, on the PDF. So we are asked, it's a two-part question, and we are first asked to determine if this set is linearly dependent or independent. So to do that, we are going to set it equal to the 0 vector. And then we can go from there. Now we'll notice, sorry, it's not a great angle, that our x cubed here and our x squared, these are both the only times that they show up in the equation. So the only way to make those equal to 0 is by multiplying it by 0. So therefore C4 and C3 have to be equal to 0, and then C1 and C2 do as well. So our C1 equals 0, our C2 equals 0, our C3 equals 0, and our C4 equals 0 to get the 0 vector. And as we know, based on our definition, if our CI's are all equal to 0, then it is linearly independent. So that is part A. Now part B, we need to find the linear combination that makes this equation true for the span of S. So to do that, we can kind of set it to our first equation. Let's see here, 4c3x squared. And now we can simply equate coefficients. So let's start with our constant. And our constant is 7 over here. And we see C1, because it's just 1 times C1. And we have another one. I believe we do, oh yeah, negative 2C3. So minus 2C3. Our x is going to be negative 12 over here. And that is going to be equal to, let's find our x's, negative 12c4 and 2c2. Now let's go for x squared. And our x squared is negative 8. And negative 8 is going to be equal to 4c3. And that's the only one there. And our x cubed is 12 over here, and just 8c4. So we'll notice that c4 is given, well, not given, but we just have to divide by 8. So we just automatically know that C4 is 3 over 2. And same thing goes for C3. Just divide by 4, and we know that C3 equals negative 2. Since we know that, we can go and plug on in and have 7 equals C1 minus 2 times negative 2. And 7 minus 4, so C1 is equal to 3. And we can do the same thing. Negative 12 is equal to negative 12 times C4, which is 3 over 2, plus 2C2. So that's obviously 18. Negative 18 plus 18, so 6 equals 2C2 and C2 equals 2. Let me just make sure I did that right. Yep. Okay, we look good. So, to make our linear combination to make this true is C4 equals 3/2, C3 equals -2, C1 equals 3, and C2 equals 2. Thank you guys.